Welcome back to my shop. Today we've got a little power supply on the bench. This is a Samlex America SEC1223, and apparently it's made in or sold in Canada, and it's made in Taiwan. It does have an FCC sticker on it, and it's UL listed. That's good. This is a 23 amp 13.8 volt power supply, all in a neat little package. It's got a standard plug on the back of it and a couple of terminals, fairly heavy duty. It's interesting that one of them is facing up and one of them is facing sideways. Don't know why that is. And the front of it's got an on-off switch, period. Appears to have a fan in it too. Anyway, it don't work. So we're going to take a look at it and see what we can do. There it is. As you can tell, well, by the size too, this is a switching power supply. Let's see if we can figure out what's in here. The input, interesting, dog hair. It's got a 6.3 amp fuse. It's got a couple of MOVs across the input. That's good for AC. It's got a capacitor, one of XY probably. And big old cap, choke coil, a common mode rejection coil, another choke cap. That would be the bridge rectifier down there. Couple of big old 680 microfarad 200 volt capacitors. Little transformer. Let's see what else. What has it got for a regulator here? For a probably, let's see, it is a really can't see that all that well. Extra light. R410A. Yeah, that's what it says. KA7500B. Alright, well, I'll look that up later and put it up for you. It's got some nice big honking parts in here. It looks pretty well built. I don't see anything wrong with it. Anyhow, it has, however, evidently been blowed up before. There's got a couple of resistors in here that have been changed out, and some smoke. And that resistor's loose. We'll have to check that when we get down underneath it. A couple of big old, I don't know, transistors or FATs, Q. I don't know what they are. We'll find out. And a BY big old scratch across the top of it. BYV72EW. So, not much else in here. Output caps are good ones, I guess. I can't tell really. Not without getting them out of here. And these are Luxons. These caps here. So all in all, I think it's pretty good. The guy says this does not work. That's why he sent it to me to fix it. Anyhow, well, let's open it up and see what's inside. Probably should have done that before I brought this up. It's not actually a manual. Well, yeah, it is a manual. I found the Found just the schematic first, but then I found the whole manual. But let's take this thing apart and see what's in it. There's looks like 4 screws holding the board on. Apparently all. There's a couple back here holding these ICs and transistors in place, or FETs, or whatever they are. So this has got to come out, and this one too. That one is the longest of them. I'll remember that. Of course it would be, because it's got to go past them. Let's see. I can unplug the input. That's nice. It's put on here with good solid spade connectors. And grounding is grounded, screwed very well to the case. And it even has what looks like some sort of epoxy on there holding on. I don't know. It's pretty hard. Okay, let's see. Is that it? No. The front connectors are connected by big old wires with screws going in the sides of these block connectors. These are pretty healthy. I mean, it's 23 amps. They figure it needs pretty healthy wires, which they're right. Okay, so that's it. Okay. Yes? Aha. Well, I'm not going to take, I don't think I'm going to take that off of there. I could work on this thing without doing it. I don't know. Okay. Well, let's see. We got, these are interesting. I've not seen these before. They're like cell pads, only they're tubes. And if we look at them, I've got dog hair in here. If we look at them, they got rips in them. And this one is completely came apart. Huh. You know, I think maybe I need to turn on another light over here. I don't know if that's better or not. Definitely more light. So, let's take a closer look at this guy. Here's the transistors, these, and this. What are the transistors? They are 2SEC1223s. Apparently from in 2012. Oh yeah, and it definitely has been worked on before. What was that resistor that was wiggling around in here? Is it this one? Yeah. Yeah, it's see it wiggle? Is it still attached? No, it's not attached. Okay, so, now, I'm going to just take a wild guess and say that these guys are blowed up. So, let's get them out of here. Because I would say that that is the most likely problem. Like all other switching power supplies, these things, they're not quite as forgiving as basically a linear power supply is. Thing cooled down on me while I was waiting. You know, a linear power supply, you can kind of give it a little bit too much oomph at one time, and it won't just die on you instantly. These guys, unless they actually have really good circuit protection, one good hit and they can pretty much leave. That's better. Come on. I'm hoping this isn't too big of a deal. Okay, this is not a double-sided board, so that's a good thing. Take you out a little bit so I can sort of stay in frame. That's awful close. Yeah, that's real close. Okay, so get the little magic box here and hook this guy up. These little testers are good. They're not perfect in shape or form, but they're good for hopefully showing us if this part is any good or not. Well, what the heck does that say? All right. The first time it said no or damaged part. The second time it said it was a resistor. Let's try this again. Yeah, that's what it's saying. See if I can get this on camera. It's saying it's a 60 ohm resistor between pins 2 and 3. So that would be the first two. Pins 2 and 3. And this is a 2SC2625. Okay, 2SC2625 is going to be base collector. So it's got a base collector short of 60 ohms. Wow. So we see on the schematic. It's nice. I like it when the schematics put those things up there like that for us. Let's do the next one. So we know that one's bad for sure. And let's see what this one says. This one says no or damaged part. Make sure my connections are good here and hit it again. Come on. Wow. Okay, that's lead length. Okay, so no, this says this is bad too. So this is a 2SC, so I know it's a transistor. Let's test it with this guy here. So BCE, and it is a NPN. So open, 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 open. Really? Open and open. Alright, so this guy is absolutely nothing at all, and according to our little tester over there, this one is a 60 ohm resistor, which it appears to be something like that, and the emitter collector is open. So both of these guys are just shot. Okay. What else we got here? This guy is what? A1, A2, K. So what are you over here on the schematic? Must be switching. Oh no, I haven't looked at this thing, so I don't really know. Wow, okay. SD1. SD1. Huh, I must be going blind. There's the two output transistors. Definitely transistors. Trying to figure out, here's the SD1. Wow, that's current sense. I don't know exactly. That's interesting. That's a new piece there for me. I think maybe we better test it though. I wonder if I can test it. Yeah. No. I don't think so. It says it's a Schottky diode, dual Schottky diode, and a big guy. So the K's in the middle, and it's charging up. To about 0.6, I guess, somewhere around there. This will go backwards. All right. Well, it's not shorted, but I'm going to have to take it out just to check it anyway. It's a pretty beefy part. Doesn't show any signs of being bad at all. And this, I hate this solder that people use. This awful solder. Okay. Alright. Well, let's see what this says. Open that direction. 0.23. Open that direction. 0.25. Alright, so if we hook it to this guy, we should get, let's make it make sense here. Put the yellow one on K, this one on the first A1, and anode 2. Hit the button and see what it says. Should give me 2 diodes back to back. And that's exactly what I got. See if we can see this. There it is. Yeah, 2 diodes back to back. So it is what it says it is. Okay, well, that I call that guy good then. We'll put it back in. Okay, so we know that's okay. I got that one busted resistor. Depending on where it's at in the circuit, is not going to make for happiness. And I couldn't tell if those things were actually shorted together or not. But we'll find out. All right. I'm going to have to use these sill pads turned around the other way, so that's good. That will work. Okie dokie. All right. So I'll be back as soon as I find some parts. Okay, well, we're back. I put this black mat down to get rid of some of the shine. I got some new lights up here. That's why we're doing this. Got new transistors. Two SK2625s, two SC2625s. Ks would not be the same thing. And it's funny, I was looking at these, and this one, the one that's actually not completely open, is the one that shows some serious burns. The one that is completely open is fine looking. That's interesting. Anyhow, so we got to put these in, but first we got to tackle, make sure that this resistor that I was wiggling around here, let's see if I can, yeah, we'll just strip this resistor back. Since those have been changed, you know what? Let's measure those and see what we got. Ohms rate. Okay. There we go. So I got what? 0.5 ohms on the leads themselves. That resistor is R8. And according to the schematic, make us a little bit bigger here. R8 is 4.3 ohms. All right. And we got 4.296. That's close enough. Here's his counterpart, 4.29, 4.29, and this one's the other one, I think, R9, 8, so 9 and 8, so here's this one. This one is supposed to be the same. And it says 35K. Okay, so that one is bad. I don't know. 4.2 ohm, 10 1 watt resistors. Didn't even bother to look at that. I should have, considering it's burnt to a crisp. Try that again. Uh, 0.26 megs. Oh boy. Okay, so I need a 4.2 ohm resistor. Have I got anything like that in 1 waters? Don't know. Might have to make something. Got lots of resistors. Well, let's see. I must give credit here to Terry, one of my ham friends. He had an entire, I don't know, 1, 2, 3, 4, 5, 6, 1, 2, 3, 5, 10, 15, 20. Well, so it's 1, 2, 3, 4 whole sets of these things. And he said, "Hey, Dave, you fixing these things for people? You want these?" Oh, well, yeah. So now I got this huge collection of resistors. Anyway, so I got a couple of 10s here. Let's see how close. Well, let's match them up. Okay. Got to come up with about 4.2, 4.5, somewhere around there. No, wrong meter. Let's see, so this would be 12 and 16. Well, yeah, that is 16. That's actually 15. In the wrong box. So let's take a bunch of these out of here and see what I can do. These all the same. Brown, 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 brown. Yes, okay. Yeah. Let's see. Brown, black. 14 ohms. Supposed to be 10 ohm resistor. These are not very close. That one's 11, 12, 12. I sure wouldn't call these things 1%ers. They're not. Some of them have gold bands, which means 20 or 10% or 20%. Then you got gold. Okay, so if I take this one and this one, 3 times 4, tell you what, let's take 3 15s and see if we can come up with 5.9. Take one more of these 15s and try that. .6. I'm going to say that's good enough. All right. However, one thing I do want, I'm not going to put those there because you know as well as I do, as soon as I turn around, I'm going to hit it, it's going to fall on the floor, and then I got a whole day of picking up resistors. I really don't feel like doing that. Oh, come on. Yeah, okay. All right. This will work. It's not exactly the prescribed method, but I have plenty of room, so we'll do it this way. Remember, resistors in parallel, two resistors in parallel is half the resistance, double the current capability, whereas capacitors in series or in parallel is double the capacitance with the same power, with the same current. So they're different. You gotta remember that. All right. And yes, it is going to stand up off the board just a little bit. That's okay. We'll say we did that to dissipate the heat better. My story, and I'm going to stick to it. All right. I'm going to use those two. Okay. Save those bits. Check my resistance again. There. What do we got? Wow, we ended up with 5.2. Okay. Interesting. I'll bet you if I get rid of some of the heat, since these are carbon comp, let's see what that did. I took it up to 6. Wow, I got 2 ohms now in my leads. Okay, tell you what, you're gonna be that way. Let's do this. Let's do a 4-wire measurement. To do that, we hit function 4-wire. Alright. So if I do my 4-wire and I short my leads together here, 0, 0, 0. Okay. Clamp it onto there. Alright, I got to get it down to here. That's interesting. I'm reading a dead short. Wow, is there something wrong with my meter? No. I did something stupid. I plugged it into the wrong spot. That would be something stupid. Okay, so we got 4. Because, let's see, short them out, 0. 3.99. I think we can live with that. They're so long, but sometimes you need them to be that long. Alright. You know, while we're at it, let's check the rest of these. Resistors and make sure that they're approximately correct. Let's see, that's a diode. What are you? R6. Got to put it back on 2-wire again. R6 is open, I think. Excuse me. So R6 is supposed to be 270K. Put that on auto. $37K. I don't know. R7. CR7. 2.6K. Excuse me again. R7 2.7K. R10. Why is my meter not responding to me here? R10 0.38. Wow, okay. And R11 38 ohms. 39 ohms. R4 4.2 ohm. Somebody has really messed this up. All right. Stupid thing cooled down again. And these guys have all come loose. They're all going to have to be tied to each other correctly because all the pads are busted off. So here's what I think happened. I think somebody went through here and replaced them, but didn't quite get it right. And I'll guarantee you that's why it blew up. Alright, so here's R10. Let's measure R10 again. 2.6K, so it's okay. My question though, R10, oh no, so R10 is going across here to here. Yeah, 34K. 34K. So I wonder if this diode's any good. Let's check the diodes. That's D4. Is shorted. Yes. Huh. Okay. Alright. D1 is okay. D2 is okay. D3 is okay. D4 appears to be shorted. Wow. Well, I'm glad I didn't just replace the transistors and turn this thing on. That would have been bad news. Okay. Aha. That one is good. So, resistor is, or the diode is not bad. Interestingly enough. So if that diode is reading okay, then according to the schematic, there isn't just going to bridge this guy here, seeing as how it's not in good shape. Okay, so if I'm still getting a short across this diode, and I am, there's only one thing there across that diode that it could be shorted, and that would be a 10 microfarad capacitor. Are you shorted? Well, this, where are you? Here you are. Does that have, it appears to have a little bit of a bulge in it. Okay, negative goes to the side with the thing on it. Alright. Yes, we have a shorted 10 mic 50 volt cap. Okay. So what do we got here? 10 mic 50 volts. Perfect. Wow, I actually had what I wanted. That's hard to believe. Okay, so this goes just to be on the safe side. I mean, this is good one. These are Nichicon, so I don't expect these to be bad. But for my own stuff, I'll use cheap junk as far as capacitors and stuff when I'm playing around. But for customers' units, I try to go with good stuff. A couple of reasons. One, I want people to think that I know what I'm doing, so it doesn't blow up when they get it back. And two, I don't want to work on it again. That's just the way it is. Alright, so now measure across that diode again. Yep, capacitor and diode action. So there's another bad part. Alright, and this guy, this little, what are you? 2.6K, 2.6, 2.7K, and you are R7 or R10. So you go back in here. Okay, good. Okay. Now we also have to take out this guy because it's the wrong value. Ugh. Wow. Okay, that was too small of a hole. 4.7 ohms. What are you saying you are? 4.2K. Alright. And that is R4. R4. Supposed to be 39 ohms. R5 4.3 ohms. Okay. That's 4.3K. Okay, so these are all wrong. Wow. Well, I guess we know why it blew up. Oh, how many of you guys caught that? Were you yelling at me when I was measuring them? Okay, that's all right. Oh boy. So all of these are 4.3K instead of 4.3 ohms. And they were fried. Alright, and we got one more big resistor in there that's been replaced, I think. What is your value? R6 is measuring 37K. R6 is supposed to be 270K. R7, although I don't know which one this is. So R4, 39. This is interesting. I'm beginning to believe, and I wonder if this, yeah, SEC1223 is definitely for the 1223. Why are all these resistors wrong? C8, C9, so R10, R11, R11, 38K. No, 39 ohms. That's correct. So that's going to be R4. Should be 39 ohms. Get one of those. I hope. Okay. R4. What the heck is going on? It says 67 for my R for this that I just got out of the box. $58. Okay. There's something strange going on there. do some wire wounds here and see what we can find. Something is not working like it's supposed to be. So these should be 39 ohms. 39 ohms, okay. Those were interestingly way off. Well, they're very, very old. Okay, so this is R4. Come on, David. Evidently it takes quarter watts, not half watts, because I can't even get this in here well. Well, I got that. And this is why you measure things before you put them in, so you're not chasing yourself around in circles trying to figure out why, when you just fixed something, that it's not working like it should, when you're absolutely positive you did it right. Okay, so there's that one. R5 is a 4.3. That would be one of these guys. Yeah, this is the kludgy part of this. I'm sorry, but I just don't happen to have any. Okay. What else have I got? R6. We did measure that as being correct. R6 supposed to be 270K. Okay. Try this meter. It says it's open. Really? I guess this, just because a resistor looks okay, doesn't mean that it is. Yeah. Now that's okay. 200.26 megs. That one's alright. Why was it reading open in circuit? I must not have just got to it or something. 270K. Okay. R6. That's interesting. This one has actually 2 holes drilled for it. As if they had something else they wanted to put in there. Okay, so that's going to be R8. That's going to be that other 4.3 ohm. Let's see. I got 15s here. So we get to go through this again. I found these other ones. They'll be a little a little less obtrusive. So let's see what I've got for resistance here. On the bottom meter, 4.2. Groovy. Alright. Chop all you guys off. And you guys off. If this was actually a customer's unit that I was shipping back into the field for somebody I didn't know, I definitely would buy the resistors for this, but I don't think Kevin's going to mind. Alright, and so then we got what? R9 is 270K. And it was burnt to a crisp. So over here, give it a half watt. I think that's what was in there to begin with. I don't know. I really don't know. I think so. Because it has two holes, bigger ones and littler ones. Okay, so we'll solder this back in. Okay, this one's going to have to actually go over to here because the trace is completely gone. That's okay. This one, the trace is partially there, but I'm just going to use it to get all the way to the end of this common line here, because it doesn't look all that great. Okay, that's not so good. Okay. And you. All right. And there's that and that. This one is busted too, so I'm going to use the rest of what's left here just to tack this in spot, but it's going to have to go up there and connect to that. This one is okay. Yeah, this one is gone also. I can't even get this one. I'm just going to blob it up so it doesn't fall through the hole. And take this one and run it down through this whole common section here. Boy. Boy, oh howdy. Now, is that actually supposed to go there, or did I just make a mistake? Nope, it's supposed to go there, so that's good. Okay. Okay. That's good. Cut the lead off. Okay. Let's let's get a little bit of squirt down in here to see if I did that right or not. Yeah, okay, that is actually supposed to connect. That's good. Okay. Alright. Okay, and this was supposed to be a quick and easy video. Change out the power transistors, Dave. It'll work. All right. That one I gotta leave. That one I gotta leave. This one I can take off. Fortunately, this isn't a double-sided board. All right. Okay. Well, let's check these now before I do anything, because I want to make sure. Watch the bottom meter on this one. If you can see it, you can't. Watch the top meter. Sorry. Alright, so my first resistor, which is R4, 39 ohms, correct. R5, 4.2, that's correct. R6, whoops, 36K, R6, 270K, and R9 is, that's wrong. We'll see what it does on the other side. R7, 2.7K, correct. R8, 4.0, that's correct. R9, which is the same as R6, I believe. 38K, okay, so yeah, there's something in circuit that's changing that. R10, 2.7, that's correct. And R11, 38K, R11. R11's 39 ohms. Okay, that's correct. Okay, so R6, come on, get on there. It does not like measuring this resistor at all. So it's measured as 48 going up, 50 going up, and that's R6. So R6, same as R9. Does R9 do that in the same way? Yeah, okay, so they're all right. All right, so all the resistors are now correct. Not pretty, but correct. Wow. All right, so there's a capacitor bad, some resistors that were the wrong value. All right. So now we got to put this in here. And fold it over about there, I guess. Let's see where they bent these guys. Yeah, right about there. Okay. And you you sort of got to make sure these things are in here where they're supposed to be, because they got to screw down. All right. All right, we'll tack it in. And we'll tack this one in, because that other one's going to take a little bit of effort. There, that's good. All right, and I got to get this guy over here because there's no pad left where it's going. Alright. And then this one. That's good. Ish. Okay. Put on my glasses. I can't see what I'm doing. This tip that I'm using on the soldering iron is actually not the right one for this, but we'll live with it. Alright. That one's good. That one's good. And this one, the trace is destroyed. And so is the pad. Completely gone. All right. That's good. 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 All right. Let's clean this off a little bit so I could look at it. Whoops, forgot one. Clean it off, make sure I don't have any shorts. Yeah. Not some of my prettiest work, but take a look here. Come on, focus. There we go. It all looks okay. What I had to do over here, this trace was gone, so I had to run it over there. The lead, this one, the pad was gone and the trace was gone, so I had to run it over here. This one was okay. This one was okay. This one, the trace and pad are gone, so I had to run the lead over. This one is okay, and this one is okay. And these guys, basically, I just ran one lead from this all the way across. All these are in common, and all these are in common, so I just ran the lead across to there. So, we have more or less reworked this thing as much as I can tell. New capacitor and everything. Shorted. Don't see that a lot, a shorted capacitor. Alright, so we're going to put this back in its case here. By the way, I'm so glad that they put all of these expensive components in here to protect that valuable fuse, which is good. Alright, so this guy I gotta find a side that's not going to short, because it's ripped up pretty badly. Yeah, that's alright, I guess. Ugh. This one, the other side is okay, but all right. I wonder, are these guys is it a center pin shorted to there? Yes, okay. Alright, so I can test that when I get it screwed down to make sure that it isn't actually shorted to the case. Let's put you in here. I would put new sill pads on here. I just don't happen to have any. See you. I mean, these appear to be okay. Wow. Click. There we go. All right, and then this one. Has this longer screw in it. Okay. All right. I don't know. I don't think that these corners ground it. I really don't. But we'll put a couple of screws in here just to make sure. This one's got glue all over it. Okay, this is getting irritating. For some reason, this screwdriver won't let me magnetize the tip. Don't know why. Alright, what the heck is going on here? Pretty close quarters. Don't screw everything down until you know you can. Alright, a little fan jumper. Hot and neutral. They colored the wires right, that was nice of them. Get this back out of the way, because that's where it was to begin with. Alright. Screw these guys down. Tell you what, now let's make sure that these guys, none of these guys are, nope, none of them are shorted to ground. That's a good sign. Alright, I'll leave those up there for a little bit later. And this side over here. I'm going to leave it turned sideways because he may have done that on purpose. Because the way his wires are running. Alright, we are off. Hook it up to a well, let's see. Let's get this here. My Tenma isolation transformer does have a current meter on it, but these things are just touchy, so we're going to do the old dim bulb test here and see if this works. It's a little thing, built it, nothing to it. Alright, turn my power down, turn this on amps, turn this guy on. So far no current, well, to speak of. Alright, well, no light either. It's lights on in the front. So, put you on volts and give her a test. 13.9 volts. Cool. Alright. Let's take this off because this will mess up the current draw because it's going through a resistor called light bulb. Alright. We know that's okay. But let's get you down here. And a couple of clip leads. We're just going to put this thing under a little bit of a load to see how it works. This little box I built quite a while ago basically is just a little what do you call it, load, electronic load. And yeah, by the way, I built a thing back here from a Raspberry Pi that has switches that are controlled by my phone. That was kind of cool. Alright, so let's turn her on. Am I hooked up right? Red to red? Yep. Alright, so what have I got power wise? Ready? Okay, so I got 13.8 volts, no current. Let's back this thing down. Okay, I wish I could get this so you could see it better. Tell you what, I'm going to turn these guys off. Alright. Wow, that didn't really help at all, did it? Okay, let's try this light. Okay, 13.8 volts. Let's draw some current. There's 500 mils, still at 13.8. There's an amp. There's 2 amps, 13.7. There's 3 amps, 13.7. About 3.6 amps is all I can draw on this. 3.5 amps, 13.6. So it's regulating. Let's see what it does when I switch the load off. 0.2 of a volt between 3 amps or 3.5 amps and nothing. Ready? There, 4 amps, 3.6, 0.2 of a volt. Alright, well, I think I'm going to call that fixed. I think. Oof, why is there? So, I think I'm going to call this fixed. It appears to work. I don't have anything else I can put more current onto it with. But, recap, bunch of resistors with the wrong value. Outputs were blowed up. Shorted capacitor. And a perfectly good fuse. You just gotta love it. Alright, there we go. Another video. Hope you enjoyed it. If you did, give it a thumbs up this way. And don't forget to subscribe and hit that bell over there on the side if you want to hear more or see more when I put them out, so you'll be notified. Thanks for watching.